Rourkela, we are going to start FDP on hardware security for Internet of Things. This particular topic is quite challenging in the sense that we are touching two aspects. One is Internet of Things, another is hardware security. The way Internet of Things have progressed the last few years, and that has touched to the 10 billions of units last 2 years back, now almost 15 billions of units of IoT devices across the globe. When so many devices already on the internet, there is becoming a serious issue. And the biggest challenge of Internet of Things is security. There is other challenges also. While we'll talk about that, we'll talk. So we thought, based on our expertise at our place, we could take up hardware security for Internet of Things. And so in this particular area, we have been working for the last 10 years hardware security, but that is in the context of mostly VLSI design and IC design, etc. But such thing can be extended for Internet of Things. So I'll go ahead with the lectures. But in the meanwhile, my co-coordinator, Professor Ayaskan Swai, who is there, will let you know about this particular FDP so that we can go ahead. We have got lectures all through across the country and abroad as well. There are people, and I hope that this week and the week starting from 4th till 8th will be very fruitful for all of you. So thank you. I'll come back for the lecture. In the meanwhile, As sir will take you to the few things as regards to the lecture. So As can please go ahead.
Okay, thank you, sir. Good evening, all participants. So I also welcome all and thank you for showing your interest to this particular course. So as sir told, Internet of Things is now a big buzzword, but at the same time, we should able to understand its basics to complex problems. So before going to the course structure, let me tell something about this AICT program. So this we are doing AICT training and learning course. This is called as ATAL Academy. As we know that the higher education system is passing through a transformational phase to cope up with the global trend. So in this regard, NEP 2020 is proposed and it is a lighthouse for this journey of transformation. And in this quality teachers community is always a potential force to enforce the changes and plays a pivotal role in development of knowledge building, knowledge sharing and its dissemination. So NEP 2020 envisages empowerment of higher education teachers with series of capacity building trainings and workshops. So in lieu of this, ATAL Academy has been proposed by AICT, and we are fortunate enough to get our proposal approved from AICT. The objective of the ATAL is to impart quality teaching to the faculties, and faculty should have a sound domain knowledge and associated skills of the subject, its application related to real life and industry, and they can able to develop pedagogy requisite teaching skills which they can distribute to their students, and at the same time they should able to create skill of analyzing a problem. At the same time, it is also increase the institutional leadership skill. So with this, now I will share my screen for the course. So already we have shared the course structure. So this course is framed like it is something like we can start from basics of Internet of Things and go to case studies, and finally we can learn the security aspects of this. So we have faculties and we have one industry interaction. So we'll start today with Professor K.K. Mahapatra sir from NIT Rourkela on Internet of Security of Things, followed by we see what are the sensors, actuators required to form the IoT system. Then we'll see what are the IoT protocols through which it will communicate with various peripherals, and as well as how it can communicate to cloud, and how it can use cloud efficiently or to store the data and process it. Then we'll also discuss about hardware security aspects of IoT. So for that we'll have Professor Anirban Sengupta from IIT Indore and Professor Urvi Chatterjee from IIT Kanpur. And these will be all our online sessions. And after that, the actual inauguration we scheduled it at the offline sessions. So that we'll do on day 1, 4th of December at 9 a.m. Followed by we have invited Professor Sudhir Mishra sir from IIT Kharagpur, who has written two books on IoT, and he's also working in IoT area in IIT Kharagpur CS department. So followed by we have an industry interaction with one of our startup company from our institute, which is now built up to a company of crores. They are working in air quality monitoring. So they will share their experience. After that, we'll discuss about blockchain on IoT. And we have set certain case studies. So faculties like Professor Sarojju P. Mahanti from University of North Texas working in smart city area, Professor Amit Joshi working in healthcare area, Professor Devanjan Das working in agriculture area. So we'll discuss the related case from here, and at the same time we'll do certain hands-on. So this is all about our course structure. In between there are two articles which are already, we'll share it and we'll discuss it. And finally we may create a report out of this, which we may have to upload to a ICT portal. So now coming to attendance. So we have shared a few links to all our participants. So I request that we take attendance in directly here on MS Team, but the attendance portal again in Google form will be opened at 8:45 p.m. to 9 p.m. towards the end of the session. I request you to kindly fill it. Okay, and it will be only open for these 15 minutes. So kindly fill in that period only. After that, it may not accept the response. So all this attendance after compilation will upload to the ICT portal, so that they will generate the certificate for you, and that you people can get at your own, maybe at your own portal. Okay, so now I will formally introduce our today's speaker, Professor K.K. Mahapatra sir, who is actually my teacher and is one of the pioneer in VLSI design at NIT Rourkela Electronics and Communication Engineering Department. He is the fellow who has started VLSI here from scratch, and now many of us are continuing that legacy at this place to distribute the knowledge to our students and to associated faculty members. So Professor Mahapatra sir has received his BTech degree from REC Calicut in 1985, then MTech degree from NIT Rourkela in 1989, and PhD from IIT Kanpur in 2000. He is currently holding a position of Professor HAG in Electronics Engineering, Electronics Communication Engineering Department of NIT Rourkela. He has joined this institute in February 2004. He has published lots of papers, and he has produced more than around roughly, I can say 15 or plus PhD student. So his current research area including embedded computing system, IoT, VLSI design, and electronic circuit and industrial electronics. So he is currently holding the IEEE subsection chair Rourkela position, and he is a fellow of Institute of Engineers in ECE division. So I request Mahapatra sir to kindly share his slide and start the presentation.
Okay, Askan, thank you. So we'll go ahead with the lecture right away. And in the meanwhile, because there are 31 attendees, we should have 50. Maybe Jagannath, you can push in the invitation. Those who are missed out for some reason or other, they can also join with us. So let me go to the topic straight away. So this particular topic is hardware security for Internet of Things applications. So exactly the same title as that of our FDP. Philosophically, I have actually delivered this lecture elsewhere, but today is tuned in the way that we have to look at it. So there are different aspects when you talk about Internet of Things. I think majority of people among us are actually familiar what is Internet of Things. There is something, a topic called hardware security, which is not very commonly used, but if you look at the whole country, very limited number of people actually conduct research on this particular topic, hardware security. We are one of them. And what we observed in the last few years, that yes, IoT is great, it's a buzzword, and it's just not a buzzword, but at the same time, it has a lot of utility. And if you look at the utility area, then the utility is almost in almost every place, whether you talk about healthcare, because many times the healthcare is becoming a concern because we talk about this health. And but it also facilitates our agriculture, very much similar in the lines of what our government plans all the time, whether it is Jai Jawan, Jai Kisan days or even today, when you talk about this. Industrial IoT, when we are talking about this, again, we are talking about manufacturing and similar, and when we talk about the what's called Make in India and Atmanirbhar Bharat. So IoT has a great future. I'll come to the details of data little later. But at the same time, it poses several challenges. And the most serious challenge is security. And however, the security has two aspects, hardware as well as software. We are focusing more onto the hardware security. And why? I'll come to that particular aspects. There's some problem, but new. There are some issues with my machine, but I'll again come to the okay, now this is this IoT, the IoT I have written, but this is something that I have copied actually from the internet. The wherever I have acknowledged that, and here what exactly we are looking at is, we said that there is internet, and then we talk about things. So there are various kinds of stuffs that is being shown over there. You can find out some of the vehicular stuffs, like there is a cycle, there is a truck, there is an aeroplane and similar kind of things. And then there are different kinds of gadgets. And in addition to that, then I've shown some of the stuffs, like if you look at this Wi-Fi and all such similar kind of things. So there are various different kinds of stuffs that is being available. So what we are trying to do is that we are trying to connect all these devices through internet, and that is what we are calling the Internet of Things. And we'll take off that what exactly is this. Maybe this is something that is known to most of you, but I'm doing it for a sake of continuation or similar kind of things. So the typical definition, if you look at the Internet of Things, refer to the fast growing network of connected objects. So the objects could be anything, but at the same time, we put a tag again that when you are talking about objects, these objects should be able to transmit data or able to collect data. That is what is mentioned. Objects are things, because we are saying Internet of Things, that is why we are calling things. But these are connected objects. Collect and exchange data, or otherwise we call it information. But that should be done in real time using embedded sensors. Okay. So the philosophy here is not we're trying to do anything an offline computation of similar kind of things, and the things are happening in real time. So whenever I have used this word real time, a typical problem that happens with the majority of us that we try to put in real time is something that happens in online, that kind of things. But real time means we actually put a time constraint, and we say that the job should be done within the specified time, and that is what is meant by real time. And otherwise it becomes little ridiculous that we are trying to collect information we are not getting, and then obviously we are not providing a solution to that. And that will say that using embedded sensors, embedded system is altogether a different stuff, but this also needs a little bit of discussion in the sense that today in the world, we are using embedded system almost everywhere, because gone were the days when we have said that we have used discrete systems. Today, in almost in every scenario, we are using embedded systems. If you look at your home, you will have so many embedded systems already there, whether it is your TV, whether it is your washing machine, whether it is your printer, and there are several things. So all that through embedded systems, we are saying that what we try to do is that instead of using discrete component, we are using a single processor or multiple processors. But in this particular case, we are talking about embedded sensors, in the sense that that particular object or thing will have sensors embedded into the Internet of Things or the objects, and that should be able to send and collect data. And we start with the simplest examples. That is why whatever examples that we come across in our day-to-day life, like thermostats, cars, lights, refrigerators, and more appliances connected to the IoT. These are the things that we almost every day we have a look into it. I'm not saying that every refrigerator is connected to the internet, but there are refrigerators which are connected to the internet. There are lights which are connected to IoT. There are cars which are also similarly, we say, thermostats. I'll come with more concrete examples a little later, so that we can justify that why security is required. And whenever I'm saying that IoT application or Internet of Things applications, then let us go back to the very basics, and we say smart home. When you talk about smart home, we have a habit of using this Amazon Echo. Most of us nowadays use this particular device because we ask lots of questions to this. Ask them to sing a song, Amazon Echo. Or similar kind of thing is Google Home. And similarly, we see talk about Fitbit. So many of us use Fitbit, or for that matter, a smartwatch. Whether it is already connected to the internet or not, but it can be connected, and that is what is one of the major applications. Then I'm using this particular word again from this government terminologies. Whenever we are talking about smart cities or smart villages, and if you expand this little more, then we'll talk about smart country or smart region. The example of this Barcelona is otherwise famous for the FIFA has started so football, but the Barcelona was the first ever one that went with the smart city concept. And then we are saying that connected car. I have given an example of AT&T Labs. And this connected car today, of course, there are many companies which are trying to handle this particular stuff, whether it is Volkswagen or Scania or there are many. But it was actually started with AT&T Bell Labs. And then we talk about smart grid because energy is a serious constraint in our country and for that matter in the whole globe. And the philosophy here is that going for a smart grid, the idea is that we are also dependent on lots of renewable energies like photovoltaic, like fuel cells, wind, etc., etc. So it's not only that we are only seriously dependent on these thermal power plants or hydropower plants as in the previous case. So how to connect them together and how to get the best out of that, that we are talking today as the smart grid. And this also comes in IoT applications. So these are some of the popular kind of IoT applications that I have put it. But if you look at the domain-wise, yes, agriculture is a domain, vehicle is a domain, healthcare is a domain, industrial IoT is another domain. And there are many. But these are the kind of words that we either come across directly or we say that these are the words that we are hearing. Because if you look back 3 to 4 years, this has started the concept of the smart city. I only said that we are extending it to villages, country, region, etc. And similarly, vehicular IoT, we are talking about these connected cars and smart grid. These are all the typical applications that we are looking at. Now, this is only a pictorial representation. There is nothing much to explain. The first one I said, this Fitbit kind of thing. And then the Fitbit, again, as you know that many of you must be using this particular device. Again, it is through a mobile app. You can connect it to the internet. And if your place is not quite having the best of the medical services, it can still be connected elsewhere and you can get the best of the advices. Similarly, another one we're putting it hospital, the healthcare becoming an issue. Because if we say healthcare, people say that yes, they're doing something. In all other examples, as you know, that whenever we say that this is what IoT does, then nobody gives importance to our electronics and computer science engineers. But if we say that we are doing healthcare, then people say that yes, these guys are doing something wonderful. But side by side, I have also put a refrigerator. This is the present day refrigerator. So you can say that you can also connect it over the internet. And just not for our advantages, but also for, if at all, if you look at that something is down or otherwise, then the company or all other stakeholders, the service center, they would be knowing, they would be visiting you and immediately take remedial actions for that. So that is what is IoT we are looking at. So this is only a pictorial representation. And now let us see that what are the components of IoT. So if you look at the components, all these things, I said that there are sensors and devices through which data would be collected. Because how do I collect data? So again, we come back to sensors, transducers, and all of such things. Of course, the sensors and whatever that we connect, whether the data is in the digital format or no, that's a big question. But then we have to connect an A to D converter. But then once we connect from the IoT nodes, or as I said that the data has to be transmitted from the embedded sensors in the object. So there has to be some kind of connectivity. So that is why the second thing that we look at, that yes, we are looking at Internet of Things or objects. There we have got sensors. Sensors are already inbuilt to the devices. Then we say that there is a connectivity. The connectivity can be of many different ways. It can be Zigbee, it can be your Wi-Fi, it can be Z-Wave, it can be LoRaWAN, it can be many different methods. You will have a complete lecture on this. And then we say that just collecting the data and sending it and receiving it, is that good enough? The answer is no. Whatever data we send, that needs to be processed. Just like we say that in a healthcare example, a person is having some kind of ECG that's been collected. But unless otherwise, this data is not processed by another expert who is a cardiologist, he won't give you an information back to you. And therefore, we are also again putting that what else you require is an user interface. And here now we introduce, because we are saying that sensors, connectivity, data, and an user interface. And these are the components of IoT, or IoT comprises all that. So that part is absolutely fine. But at the same time, I just wrote down the first ever line when we try to push into our topic. It may be noted that all these components need power. See, whatever you say communication protocol, it will not run without power. Similarly, you talk about anything that you say about data processing, you require a processor, or you require cloud computing, you require servers elsewhere, they require power. User interface also requires power. So also your sensors and the devices, they will run on some kind of power, depending on the kind of sensors. And here that because we are connecting them over internet, then there is an issue that whether we can do everything without security, or really security is required. The answer is yes, we require security. So as I said in the beginning, that IoT has two major challenges. One is power, that how do I power these devices? And the simplest answer, most people will say, what is the big deal about this? There is a GridCo, there is NTPC, there is Power Grid Corporation of India. Don't you have power? The issue is not that. The issue is that these devices will be connected in the remote places, or in some places where you may not be able to connect your the power that you are providing. Or is that power, then again, in most cases that would be requiring a DC power, or the AC to DC converter, and again, all other stuffs will be required. And then how do we manage this? Then we say that we require power, or we collect power from something else, some renewable energy. So that is why we say that we may be using photovoltaic cells, or we may be using wind energy, or we may be using piezoelectric. Somewhere we have to collect power and power these devices. And this powering these devices is just not for a moment or something of that kind, but it is 24/7, 365, all the days round. And similarly, because we are saying that in the beginning, I told that whenever we are talking about this IoT, we said that yes, there is an object, but at the same time, it is sending and collecting data. And if at all this data is manipulated by whatever means, if there is an attack or whatever, then there is no point. So for example, the simplest example, and what would catch the common people around, may not be very catchy for an engineer, but if you say the common people, I say that there is an ECG that is taken from a patient that is sent to, say, Rourkela is not one of the best places for the medical facilities. So we send information to AIMS Hospital or Delhi or Apollo Hyderabad. But if the ECG sent is not in the correct format, or it is manipulated, The doctor at Apollo Hyderabad would send you some information, and then you are in deep trouble. So what we want that whenever this data moves from the object to the server and vice versa, or when we collect the information, it need not be, or it must not be actually manipulated in any ways. Okay, and that's the reason why we say that the security is the big challenge. Now, let us come to the market that will give us. So I made this cross check only today, as on 2022. Today we have 14.4 billion IoT units across the globe. And in another 2.5 years' time, this will go up to 75 billion IoT devices. This growth up to 14.4 took a reasonable amount of time, but this is going to be heavy because of the fact that right now there is an immediate growth that's happening. And because everybody is demanding that, it's not that these IoT devices is automatically coming up, it's coming because of the choice of the people. Imagine just that how many people were using Fitbits or the smartwatches a few years back. But today, almost everybody says that I want a Fitbit and make me a connection to the some place in the internet, and thereby I get keeping the right kind of information throughout. And the revenue growth, and the revenue growth is particularly for interest for several reasons. This is the $1.9 trillion and the 7.1 in 2020. So that shows that the kind of growth almost 3.5 times in 7 years of time. And this figure makes us interested, saying that if the revenue is high, then you can imagine that obviously the jobs market is going to be high. Otherwise, see, once you say that the revenue, similarly particularly for the teachers like me, you, and all of us, will say that yes, this is a catchy area. So therefore, there will be sponsored projects as well as consultancy projects which would be available, because it's so many revenues is already there. So we have to cast that from the market that yes, people are working on this and companies are trying for this. So we will have to handle this particular stuffs. So that is what it said, that the market is actually growing. And here I'm just taking it a little more examples when I say that heart monitoring implants. And these typical examples are such that the common people will feel that yes, electronics and computer engineers are doing something meaningful. When I say heart monitoring implants, and I mean that needs a connection to the IoT. Remember that the pacemaker is a kind of surgery that has been happening nowadays, which has become very common. And pacemaker is not a replacement of heart, but at least it facilitates working of the heart better. So therefore, whatever implant that we are putting it inside the human body, if it can send a message out, then we know that whether this particular device is working properly or it is not working properly. Does it require a replacement? What is the battery life? And so on and so forth. When we talked about pacemakers 10, 15 years back, at that point of time, people were concerned about the power consumption. And if you look honestly that today, whenever a pacemaker is put inside a human body, then you say that it roughly works for about 10 years. The 10 years is not a magic number, but they say that 10 years, and based on the low power VLSI design, it is designed in the subthreshold region. So that one was the case, but later on they said that it's not only that you are trying to put in a pacemaker, designing it at low power, but also make it whatever implant that you are doing, make it IoT compliant. Then these biochip transponders on farm animals. This have said typically farm animals so that we can look at the health of the animals other than human health in the first one. Second one we say talk about the farm animals. And at the same time, we also can say that if at all we put a biochip transponder on other kind of animals in somewhere in other places, then we can identify them that where they are. And then we talk about the automobiles with built-in sensors. This is becoming very important now, and particularly for the vehicular IoT. And this will not only save us from accidents, because as regards to this, we say that we can implement a lot of things inside the car. Say whatever features that you look at in the today's cars. For example, if you look at anti-lock braking or collision avoidance system or whatever. But besides that, there are other types of things that suppose somebody hits your vehicle, then there are issues, and then that crime assistance can be tracked in, and so that it can be helped out. And then we look at these field operation devices that assist firefighters in search and rescue. Okay. Now, if you look at these examples, these are certain examples which are, if it's not being done correctly, this will lead to catastrophic scenarios. I mean, if you say a heart patient and if it is not monitored through a particular cardiologist, then he's likely to die. Similarly, farm animals. Similarly, we say that the automobile is likely to face a particular trouble, not just for our comfort. When you talk about cars, we say air conditioning. Yes, that's for comfort, but that is a requirement also. But we say about anti-lock braking, we say about the fire coming in, we say about the other things which are dangerous. And this could actually save us from the catastrophic scenarios. And I said that fire fight, which can happen at any particular place, and how exactly this is being done, that has to be taken care of. So this I said typically the catastrophic scenarios. The only other example, there are many other examples that you can always think of. And when you talk about the aeroplane either landing or taking off, whether the stops are, the runway is free or not, that one has to look at. And if it is not free, then the pilot has to be informed well in advance so that you can think that that is the reason why the guy will be moving in the air for some more time before he actually lands there. Imagine that this data transfer has to take place when I said in the beginning that is done through embedded sensors in real time. Okay, and the real time here it becomes a requirement, because if you say that an aeroplane is now supposed to land, but runway is not free for whatever clumsy reason. And if that guy does not get the information that the runway is not free, then he comes down and then he meets an accident and it becomes a catastrophic scenario. So therefore, I said in the beginning that in the real time, let us don't confine ourselves talking about online, this, that. And we must say that the real-time system means it has to meet a specific deadline. And the other two examples are not catastrophic scenarios, but this only we talk about the current market scenario. We said smart thermostat systems, just not the thermostat, but it's being used in industry in many places, and washer dryers for remote monitoring. Okay, because you say that you have given something into your washer dryer. initially it gave a time of 3 hours, 20 minutes or whatever. If it is a combo device, normally it takes 3 hours typical time. But then you are not going to the laundry again till that 3 hours, 20 minutes is complete. But sometimes it might take little extra or little less, or there is a power shutdown, or there is some other issues that have come up. So you will be intimated that wherever before reaching the laundry that to take out your clothes out. So that has become a kind of necessity. So that is what I wanted to tell. Sometimes we people as consumers have demanded such things, and that is why this IoT has actually taken place, taking lots of care about that and building devices in a similar phenomenon, similar ways. So it's just not for comfort, it is for our requirements, and it's in many cases it's a mandatory requirements. As you say that with the support of IoT, we can actually avoid catastrophic scenarios in many places. Sometimes my network is actually I'm sorry, I'll come back. Yeah, now here we are talking about the why be concerned about IoT. Because that's why I have put a huge question mark over there with someone is there. And this is again borrowed from internet. This is the one. The question is, it is just another computer. The answer is yes. All of the same issues we have with access control, but at the same time, we are talking about vulnerability. And then management we have to do, patching and monitoring. Now, the problem that is happening because of the fact that network with 10 lakh devices or more, here I put 1 million. Any compromised device is a foothold on the network. Anything that you are going for a compromise, the whole thing is gone. Now, these are the questions that is being raised. Are highly portable devices captured in vulnerability scans? So there are portable devices and they're connected to the internet. Are they being caught? The answer is you have to identify that. If it is yes, there is some kind of vulnerability and it is connected in a scenario in which we have got 10 million devices, or sometimes today we say 14.4 millions of devices and billions of devices. So that's becoming serious issue. What is your network perimeter? Means we will actually use several gadgets and several things, but we are obviously using some kind of connectivity technologies. So if I say Bluetooth, you know that how much distance you can cover with Bluetooth. Similarly, if you say Wi-Fi, how much you can connect it to the Wi-Fi. And Z-Wave, we also talk about NFC, near field communications, and similar kind of scenarios. But at the same time, if that particular device get a connection to the internet, means by whichever means, and then there is an issue, then you are likely to be in trouble. And then the question, again, additional question comes, are consumer devices being used in areas like healthcare, where reliability is critical? See, again, I'm using healthcare and criticality together because that is something that is really understood. All other things, most outsiders criticize electronics and computer engineers that these guys are doing this research only for publishing a research paper or similar kind of things. But at the same time, one must realize that we not only, maybe yes, we publish a research paper, that is absolutely fine. or we submit a patent, or we get a project that we have to do as a teacher for our growth. But at the same time, we are doing something for the nation. See, if we can do laser surgery, today it is happening. It's not only the doctors that they have done it, but the engineers are playing a major role over there. Then the next part is this one. Do install device management software on other computers. Is that another attack vector? That is the way that, because we are saying that so many devices on internet, and if at all anything is on risk, that could create risk for them. Some problem is happening. If you look at all these individual questions, then you find that these are actually creating issues. But at the same time, if you look at this threat versus opportunity, because we have been compelled to use it today, IoT. The first thing is that consumers ask for that, companies built it for us. The electronics engineers are only facilitators, so also computer engineers. And we did it, and people said, great. But this is what is the question. If misunderstood and misconfigured, IoT poses risk to our data, privacy, and safety. And that is particularly important. Is not only that I'm using this particular word privacy again, because sometimes when you talk about Fitbit or your ECG, need to be transmitted only to the doctor, not to any other place. That is what is privacy. And safety part, no manipulation. And if understood and secured, IoT will enhance the communications, lifestyle, and delivery of services, which is already being done, but at the same time, we'll look at this. The next part is this hardware security. But in the meanwhile, I'll come back, and if you have a specific question, please raise. Otherwise, we'll go to the next one. Or if you need a break, we can break for 5 to 10 minutes, because at 7:50 we are supposed to break for 10 minutes. Particularly the outside participants, please, you have any questions, please raise it.
You can.
Yes.
Sir, this is Ashkan. So they can raise hand, I will allow them mic, or they can write in the chat box also.
Okay, sure. That's not a nice. So let us, it's 7:50 now. Let us have a break for 10 minutes. We'll come back at 8 o'clock. Is that fair? Fine, Askan?
Yes, sir. We'll be online. You please come back.
Okay. We'll take a short break and let them also have a small break, so that because this is going to be slightly delinked, we are going for the security aspects in the next part. I think our 10 minutes break is over. We should continue now. I just said that because we are going to have now a slightly different domain, hardware security. Now the purpose is to link this to the IoT. The whole thing is that whatever we have talked so far, and because you have been pretty familiar with IoT, this is what is my guess, and I guess, and even if you are not, whatever we have done and whatever we'll be doing in the next couple of lectures tomorrow and day after, primarily tomorrow's lecture will be on sensors transducer and again on connectivity technologies. On the next one, you'll learn a lot about IoT. Here we are talking about the security and what are the future directions, particularly for hardware security, because we are saying that, and is it important for IoT applications? Now the question is that IoT needs security, there is no doubt about that. And when we say that IoT needs security, and then can the security be handled in a software approach, or do we really require a hardware security? The answer is yes, we can do software security. We can also do hardware security. We can have a hybridized method, but we have to choose the best of the possible scenarios. Now just imagine, let us look at, you have got a device for the IoT applications, and today's IoT application in most cases are embedded processors, because we said it is the embedded systems, and now they are connected for various IoT applications. Just the simplest, if you look at your home, your TV, or you say that your washing machine. Now that is now connected. That's an embedded system, so it has a processor. Now, if I want to add security to that through software, how do I manage this? So I have to write few lines of codes in that particular processor which will run it. And it will try its best in the software approach to save your gadget and no malfunctioning really happens. That is what is being done. If at all, we'll adopt software security. But when I say hardware security, then the advantage that we get is that in the software security is the same IoT processor which is running the extra lines of codes for adding security. It may so happen that we get our IoT application done, but at a compromised scenario, or it is a little downgraded performance. Okay. Otherwise, your processor is going to be further complicated, and it may not provide all the possible securities that you will be looking at. Now, when I say hardware security, so this will be a specifically designed integrated circuit that will have security right over there, and it has been optimized for that. Okay. And now, so the question many times comes that whether you are going to use a altogether separate hardware for this, the answer is not necessarily. Sometimes it's the same IoT processor, but we add a piece of hardware into that particular processor, and that particular part is exclusively designed for the security which will take care of that. And one of the companies which is working hard on this particular, almost every company is now concerned about this, but NXP Semiconductor is the one which is looking at it. They say that at the root, we have got silicon, is the heart of the device. We have been using silicon throughout. So therefore, silicon is being used, and it is difficult to tamper silicon rather than it's much easier to tamper the codes. And the root of trust is your silicon again. And now again, we'll talk on this third party stuffs, but let us now look at that why this hardware security requirement is there. See, the whole issue that if you look at, the globalization has led to significant changes in semiconductor design and manufacturing. Because of the fact that three different scenarios that I'm putting it. First one I have said, dependence on contract manufacturers, like we said TSMC or other global foundries. They would manufacture our chips, and then once the chip is manufactured, then it has to be tested. So the testing also has to be done. Again, that particular word we use in VLSI design is OSAT, outsource assembly and test for assembly, packaging, and testing. That is what is OSAT is doing. And the first one I said, we are also dependent on contract manufacturing. Then the second one we are saying is the dependent on service providers and consultants involved in a design process, for starting with design, testing, verification, and post-silicon validation. And the third one I have written in the dependence on the third-party vendors, and particularly the application domain. Now let us look at the first point, and that is why you will realize what is the importance, that whenever we are designing an IC at any place in our country, not really that we are manufacturing this. So for example, if I say that I want to create an IC in NIT Rourkela, all the best that I can do is the design. But beyond that, we don't have fab facilities. And for that matter, in our country, there is hardly any serious fab facility except for Semiconductor Complex Limited sitting at Chandigarh. And that is under MAIT now. Earlier it was under ISRO, and they are doing manufacturing. That whenever we want to do it, we'll have to go to them. But besides that, there are other places where manufacturers are available. Like one example, we say TSMC. There are other global foundries also available. So the design is to be done at a particular place. Manufacturing is to be done at another place. And testing again has to be done at another place. So it's not that if you want to fabricate an IC right over here, that can be done. Even though you may have manpower, you may have intelligence, you may have skill set, everything, but that's not possible that we don't have foundries with us. The reason for not having foundries is again the cost and the policies adopted in various countries. Somehow in our country, we have not been able to get into the semiconductor manufacturing. Right now, there are lots of news. Hopefully, that will get more number of manufacturing hubs. Maybe we get also some foundries in our country other than only SCL, Semiconductor Complex Limited. But till that time, we have to depend only on SCL and maybe other foundries across the globe. And we have to depend on OSAT because again the testing, and the reason for not having this is again the cost. The cost in the sense that it is too much expensive, and unless otherwise we don't manufacture it in a bulk number, we will not be able to meet the cost aspect, and therefore we will become a loser. Okay. And besides SCL, if you look at the educational institutes, again, we have only at Indian Institute of Science, Bengaluru, and then IIT Bombay. These are the two places where they have got some specific manufacturing scenarios where transistors and small size chips can be manufactured, but not the kind of chips that we will be looking for. So that is becoming an issue. And similarly, the other labs, like if you look at the ITA will be having something, and BEL, Bharat Electronics Limited, has a small manufacturing unit. Then DRDO labs have a little bit, but not much. So for a proper IC and in the proper technology that we want to manufacture today, we are actually dependent on the proper kind of foundries, and which is normally not available in a place where the design is possible. Then we are talking about the service providers. And when I talk about the service providers, and then we say, because the every design that I cannot do at my place, I am dependent on some of the service providers. Not only me or my students, but it's also applicable to the various companies. They may not have an expert in everything. And when they don't have the experts, they will seek for the consultancy in the who will provide them the right kind of consultancy for this one. It's only not only for the design, but also for the purpose of testing as well as verification and post-silicon validation as well. And then talking about this third-party IPs, this third-party IPs is a requirement, particularly in the digital IC design, because the total number of transistors is actually too heavy. Too heavy in the sense that I'm not talking about a simple D flip-flop or similar kind of thing, but talking about a reasonable IC which does something. If I took out my own experience at this particular place, we have designed an IC some 10 years, that's the first ever IC from NIT Rourkela, 10 years back. And we use some 3 to 4 millions of transistors. And if we did that, now imagine that putting that many number of transistors and then designing every component becomes a really cumbersome task. So therefore, what normally the IC designers do is that they depend on this third-party IPs. Third-party IPs means, see, you look at a processor, then you know that the processor has register, it has memory, it has ALU. So these things are already available either with a copyleft permission or with a copyright permission. If it is copyleft, then of course source code would be available. But if it is copyright, you can ask the company, pay a little bit of money and then get it. But imagine that these are not yours. You as a designer don't own it. You are dependent on someone else. And similarly, when you talk about the application domain, here is an interesting thing that let us look at some of the companies which are great in their domain. For example, if I say vehicular domain, if you look at Honda or Hyundai or Volkswagen, they are very famous companies as regards to their cars, their transport that is there. But they don't have an IC design house built on them. So they have to depend on someone else. So they will ask someone else to build their ICs. So based on the application domain, again, we are dependent on someone else. So what the moral of this particular slide is that whenever we are saying that we are going to fabricate an IC, we cannot do it independently, else we are actually dependent on several parameters for fabrication, for testing, for consultancy, and our dependency on third-party IP vendors. Now, so what it says that these changes on the fragmentation of SoC design, nowadays nobody call it an IC anymore, integrated circuit. They call it IC in some places, but in most cases they call it system on chip, because we are actually targeting a system, one main chip, and maybe there are a few peripherals, but or a single IC which is actually a system on chip that will have almost everything that would be required in that particular application. So whenever we are going for this design, we are saying that we are dependent on across geographies, and these third-party IP core vendors, manufacturers, service providers are not only that they could be placed in different countries. This fragmented business model in both design process as well as semiconductor supply chain raise several hardware security issues. Now you would be saying that what are the security issues? Yes, we are dependent. Yes, you are dependent, but look at this. When I say that dependence on the third-party IP vendors, how do I guarantee that whatever he has supplied to me is correct? It may not be the correct IP. It could have some serious bottlenecks, or it could be really dangerous for the when I'm trying to do this one. And then I'm talking about the service providers and consultants. Imagine that I was working in, say, TI, Texas Instruments. I left my job. I am a consultant. So maybe I am having jealousy with that particular company. I've tried to get a bad name for that company now. So that is what could be an issue now, that they are dependent on me for the purpose of consultancy, and then I do something wrong when they are providing me this one, because they may not be able to catch me exactly. And similarly, the manufacturers, when they are doing it, you don't know what exactly they are doing. They may provide a serious issues with your IC, that is, or SoC that you are doing. So that is why we are saying that when we are handling them across the geographies, then we are likely to face issues. I'm facing some network issues. I'm sorry, some issues are actually happening over here. So in this case, let us go one by one. The first one I'm talking about is counterfeiting and overbuilding of chips in an untrusted fabrication facility. Counterfeiting, there are two aspects. One is this overbuilding itself, that I ordered for 1 million of ICs or SOCs. They built 10 million, so then you don't have a control of how to handle this. And then another thing is that the aging process that would happen over there. And then talking about this IP violations, that you never know, you are dependent on someone else, and because there are IPs which will be available with copyleft permission, somebody does some kind of malfunctioning and then you are in trouble. Or I as a consultant did this particular one. This hardware Trojans, all of us heard about this virus in software, but here we are talking about hardware Trojans. So this will be again that whenever we are designing our ICs, we write our codes into the ICs in a manner in which the IC will behave in a totally different manner that is normally not expected. And then similarly, we are talking about the test and debug security. There will be problems over there, and different side channel attacks on typical cryptographic codes and sensitive assets. And whenever we are talking about this side channel attack, we are not trying to extract the exact information from the IC, but through these particular phenomena, that the power analysis based SC. So every IC will sort of give a typical power analysis, and through that particular power, the attacker can find out what information is available. So through side channel attack, what they would try to do from an IC or SOC is to extract some relevant information from the, and so that could be leaked. So that can happen through power analysis. It can also happen through timing analysis. So every IC will do a timing analysis that can be done. As we have studied in microprocessor courses, we do timing analysis. Similarly, here also for the ICs, we can also do the timing analysis. Similarly, DFT or test infrastructure based, there also we can get the information. And fault attack based side channel attack, or the electromagnetic waves that it emits, there also we can get this particular one. And then also we have multi-level attacks. When you talk about multi-level attacks, means the attacker would try to get your information through this combination of two, say power and timing. They will add it up and they will extract information from these things. And now the question is that this is possible, and only thing that we have to do is that we have to develop counter measures for this one, so that we can look at it, how to handle them. Then talking about this counterfeiting, we say counterfeit chip is the component with discrepancy on the performance or characteristics, but sold as a genuine chip. See, this is because there is a quality control that is being done before the chip comes out. And here we say that when you talk about the counterfeit, there is some discrepancy, but they clear it. When they clear it, then we don't have a clue now what is correct or not. And what are the possible scenarios? Then we say the recycled parts from an obsolete electronic equipment that's being reused, and unlicensed overproduced parts. This is always the most serious thing that can happen. Particularly, you imagine that when competitors are there around. Say, I'll give an example so that you can appreciate it. So suppose, for example, if you look at the cars in our country, then every car has developed some of the protection features for its car. And imagine that Honda has come up with a kind of IC that it will try to control every parameter inside it. Now, Honda being an automotive company, it will never fabricate its own ICs. It is dependent on someone else. And it's also dependent on the Fab Lab. Now, the Fab Lab, the Honda company has ordered for 1 million units. Now, they fabricated, let us say, 2 million units. They sold 1 million units to this Honda as per the memorandum of agreement. The other 1 million is free. They can sell it to another company, say, let's say Hyundai. This Honda and Hyundai are purely my thoughts. It's not that, I mean, what I'm trying to say is a kind of example that what can happen. Now, the Hyundai gets this at almost at free of cost, because it doesn't spend anything for the research. It doesn't spend anything for this one. And they just put the material cost and little extra to the company and they get it. Now, who is the loser? The original designer is the loser. So that is the overproduced parts. These things are happening not only in these ICs, it's also happening in the medicines. It's also happening everywhere. So there are different protection mechanisms for this one. Medicines in the sense that suppose a particular company, say Dr. Reddy's lab, did a lot of research, came out with a particular antibiotic, and they is being fabricated. Now the manufacturer does whatever is the demand to the Dr. Reddy's lab, it gave it. And they kept something left with them and sold it in another name to the market at a much cheaper rate, because they have not spent, only the material cost is now required. So that is why that is becoming the overproduced parts that coming out of the foundry, and out of spec or defective parts coming out of the OSAT. Because the OSAT is supposed to do a testing and then give a declaration that yes, this is correct, this can be taken up. But there are defective parts, and those defective parts are now becomes a part of the things. So it is difficult to mitigate the recycled parts from the obsolete equipments entering the supply chain. Now they have introduced that. Now the choice is yours, that the detection techniques and trusted source of supply are the possible solutions. So there are, I'm not saying that there is no solution. There are solutions. So that is why I said the detection techniques are there. And trusted source of supply. So the trusted is again a relative term. And so whatever you think trusted, it may not be trusted at all the time. So you have to look at it. However, as I said that it doesn't have a solution, the answer is no. Yes, it has a solution. It is possible to develop techniques to mitigate counterfeits, particularly the overproduced part and the obsolete equipment, the aging part, the defective parts, that has to be taken out. Now here, this one is a kind of taxonomy. So the counterfeits can be many ways. So defective comes from the outside. Outsource assembly and testing, overproduced, extra production that you are doing, cloning, that you have given the design, then the clones are coming out. And whenever we are talking about clones, we say that either it is pirated or it is done through the reverse engineering, because we have submitted everything to the manufacturer. So then the cloning. And then we say that tampered. Tampered means either it's a backdoor or silicon time bomb. By silicon time bomb means this becomes a little bit confusing if you are not familiar with this particular term. So here it says that your IC works absolutely fine for 30 days, but the way it has been designed that exactly after 30 days, it will misbehave. It will misbehave in the sense that suppose imagine that you have nowadays got integrated TVs where your TV will be functioning absolutely well for 30 days. On the 31st day, it starts showing all kinds of problems. So you will say that that silicon time bomb has been activated, because the time bomb is again that exactly after a similar time period that you are trying to do it, and this is being done, or why this should be done is to get a bad name to a company. And recycle, and when you talk about the recycle, as I said, that obsolete components or the aging part. And then how do I detect this? Because we say that these are the problems. Yes, absolutely, these are the problems. These problems will be there. And many times, as I have said, that we have neglected those things in the IC design. And you will say that what it has to do with IoT? See, IC design is only one part, but the ICs are now part of embedded processors. And we have embedded systems almost everywhere, whether is the typical healthcare application or your agricultural application or vehicular or everywhere. And so, or what it means to say that your IoT processor has an embedded system or embedded processor, and there all these things can happen. So if that can happen, then we need to look at that how to protect against them. Now, for coming to that, we say that how do I detect it? Then I say that yes, aging-based fingerprints, where we can do the path delay analysis and early failure rate. So there are certain additional testings that we have to do on whatever normal testing, whether your IC functionality is working. We'll have to find it out whether it is it's a brand new IC or it is an aged IC. Similarly, the electrical inspection, we will have to again conduct additional tests, and physical inspection that includes SEM and X-ray imaging and optical inspection and so on and so forth. Since I'm sorry again, there's some issues happening over the network. This one, just in the beginning, whatever I have told, I'm little apprehensive and making it a larger one. Anyway, let me try it out. When I said IP course, this soft IP, farm IP, hard IP, here what I'm only trying to show you is that where this manufacturing and all other things are happening across the globes. So you find a lot of stuffs in this North America, and then there are certain amount of things in Europe. In India, we have only shown Bangalore. And there are a few other places like TSMC is famous one, so that is why there are few things that is being shown over here. And so all that it says is that the global distribution of semiconductor IP vendors, so is across the globe, so we have to depend on others. Now coming to this IC classification, so if you look at this one, we said hardcore and softcore, we are trying to make a difference between them and then identify that as regards to the hardware security aspects, then which one is better. Then if you look at structure, in every place you'll find that the hardcore is better compared to the softcore. Here we say predefined organization and behavioral source code. So this is becoming technologically independent. So this is becoming a predefined organization. Modeling, if you look at this one, we say that it's modeled as a library component, but the soft core can be done through various different technologies. Flexibility, it gives you a lot of flexibility, can be designed, but the moment you add flexibility, then there is a problem of misuse. And here it cannot be modified by the designer. So if it is a hardcore, it's already done. Then timing closure, here you will say that it's already ensured. Timing is not guaranteed. Softcore, it's not guaranteed. So therefore, again, you know that your issues will be coming. So here we are saying that the source code will be available. Here we say it is strong, usually corresponds to a layout. And then the examples I have put two things, FPGA bitstream and GDS-II for IC layout. Here we say VHDL Verilog. See, if you look at the previous one and this one, the previous one, if I look at this one, sir, I've said that I have put in three different kinds of IPs, which I said that soft IP in SDL code. Normally, whatever we write in the format of our Verilog VHDL, and hard IP, that is why I said that physical design IP. So where the tampering is actually less. And farm IP, farm is always in between soft and hard. So that is why we said that always go for this hardcore IPs. And then this IP protection techniques, remember that IP is being available at different places. And all of us are dependent. All of us means all the digital designers and the mixed signal designers, because mixed signal would again contain digital. Remember, digital and analog, they are two different kinds of design. And digital is a number heavy, and therefore we are dependent on IPs. And that IPs are not designed by us, it is being designed elsewhere. So the protection is passive and active techniques. And passive techniques, many of these techniques already known to many of us. We say watermarking is a standard one. Active techniques, functionality is unlocked when appropriate keys are applied. So that is why it becomes the better technique today that only you are a genuine user, a genuine customer, then and only then you will be provided the keys. The IP protection during evaluation. So during evaluation means whenever we are looking for some of the IPs which are mostly developed by the third parties, and if they want that this has to be developed by everyone, so they make it free, but they have to ensure that the right kind of people evaluate it and not the fraud kind of people do it for this one. They also make the evaluation period limited, and they will say that specialized keys and they will provide for doing this. uh, okay. Some problems with my stuffs. Okay, let us go this way. It's little less visibility, but in any case, we'll share you all these slides with you. There is nothing, so you can look at. Now, in this particular case, we are talking about these hardware trojans and their taxonomy. This is a huge topic, but at the same time, I'm just trying to cover it up. And let us look at this insertion phase. Means hardware trojan, if I look at where the trojan can be inserted. See, trojan can be inserted if you look at all the places, specs, and the specs will be provided by the design engineers in the sense that the consumer will give its own ambitions that this is what he wants. He will provide his requirements, but the design engineer will always come up with his specifications and then he will design. So at this particular point also he can insert a trojan. Design also it can be done. Fabrication, yes, it can always be done because it is going beyond your hands. While doing testing, it is also done elsewhere, not at your labs and assembly. So this is what we said in the beginning, that contract manufacturer and OSAT. And the abstraction level, if you look at all these levels, if you look at an IC design, starting from system to RTL, to gate, to layout, to physical, all levels we can insert this. And activation mechanism, yes, activation can be done always on or it can be triggered. And most of the time they play with this, the triggering one, so that the whole thing can bring a bad name to your company. And internally time based, just like I told, this time bomb, and physical condition based. Physical condition based means normally it is working fine, but something, because this can happen many times in the when your IC that you are putting inside a device, it can be little bit uh, stress or strain that can happen over there. And this can be done both ways, the triggering, external as well as internal. And now this effect is the most uh, serious one. Change in functionality degrade the performance. So the change in functionality is the most serious one and degrade the performance, and leaking information through that side channel. And this denial of service is DOS. And then where it is located, location again can be at any place. See, if you look at this, I said processor, I said memory, I said IOs, power supply, this clock grid, because this is moving everywhere. And now physical characteristic, if you look at the hardware trojans, how it is distributed, whether it is distributed, what is the size and the structure, this is what we'll have to look at. Now, the hardware Trojan insertion points that we are talking about, and these are the possible scenarios in the whether at RTL level or gate level list or layout design. And who can do it? If you look at this, the third party IPs, RTL, they can do it over here, over here. In-house IP development, where it can be inserted. SOC bus integration, it can be done. Layout, once it is a layout, it actually has no meaning, and this also has no meaning, but here it can be done. Now talking about the kind of benchmarks for this third-party IP, yes, benchmarks from CrossTop can be used. No models available for the layout. For others, there is no such layout. Now, how do I detect it? Because this is the biggest question mark that comes over here. How do I detect it? If you have done VLSI design, then you must have read about this functional verification. And so using functional verification, we can always try make a sincere attempt. It is difficult, but it can be done. Needs special stimulus generation to trigger hardware trojans. And now the next one, we say that ATPG simulations. Whatever software signals can be marked. So we have to do additional testing again, and then we can do this. And this is again can be done through STA or static timing analysis. Combinational loops must be carefully observed in STA to find out suspicious signals in the design. And formal verification. First one is functional verification, and formal verification again, model checking. And this is a powerful technique. And many of the digital designers actually take up this for hardware Trojan detection. And designers are well versed in developing properties to check the design specification. But at the same time, see, you start with requirements, go with specification, then we go with the design. And but it needs a lot of experience and develop security properties to check what design should not do. So this is why it is said that yes, it is possible, because these are all pre-silicon. IC is yet to be manufactured. And so we have to take enough care about this particular point. Because, and here you would say that you are doing it in your lab, why you are so much worried about the pre-silicon? Yes, I am doing it in my lab, but I am dependent on third-party IPs. That is why I'll have a concern about this. So I'll have to take care about all these points and make sure that I send the right kind of things. And here again, I'm not really having a control because post-silicon. And post-silicon means already you are done. And but then you have to take care about this. And here this is a big table, and so you can have a look. And so we'll not have much time, so I have to now make a little bit of rush. So there are we said that the description I have given in the this particular column in the different groups, and the same names have been untrusted third-party vendors, Foundry, the EDA tools. EDS tools start not only from Synopsys, Cadence, and Mentor. They are the tools, these are available, we are buying it from the market. But there are lots of tools which are available with copyleft permission. Some of these are available in the university website, some of them are available in other labs, or somebody provides you. So you have to be a little careful. And whenever we are talking again from the EDA tools, you know that many among us also try to use this cracked version. They don't want to buy. So then again, how do you trust that? Then we talk about this COTS, commercial off the shelf. We buy to try to buy something. Then untrusted design house. Again, this is more or less like this. And fabulous associate design house, what it is exactly trying to face, similar to the companies I said for the automotive, I said Honda and Hyundai and all this. But I'm sorry, I just but a jump. But at the same time, if you look at the TV companies, also Samsung or LG or Sony, and they also become fabulous SoC design houses. And when you look at this, untrusted SoC developers with trusted IPs, now where exactly the attacks are possible, that is what is being shown over here. And now there is a question that this hardware Trojan defense. So here I have more or less written down the summary over here. There is a good possibility that hardware Trojan will go undetected, where in both pre-silicon as well as post-silicon. So therefore, the on-field defense against ST is important. Now, what are the stuffs that we are taking care of? We say that currently hardware Trojans is based on the following: securing crucial assets in a processor like program counter, DRM, etc., and security during booting, so that we assess it that in the beginning. So this should happen provided the first one is happening, and then the access control. That also you have to check, and information flow tracking. And the test and debug security also I mentioned in the beginning that we are dependent on the OSAT. So the test and debug security is elsewhere. So in the current SoC design, corner cases like clock domain crossing, crosstalk, these things are there, and this has to be identified, all these corner issues, during post-silicon validations. And again, in the post-silicon debugging, that also you have to check. And the regular assertion of checkers means this again has to be done through the additional testing facilities that you have to put it. And silicon odometers, like the standard odometers, we are more familiar with our transmitters, but silicon odometers also are there, particularly to look at the aging aspects, that how aged it is. So this also we have to take care during test and debug. And access to instruments in the on-chip environments will compromise the security of SoC design phase. So the test and debug security is important. And then finally the solution. Cryptographic techniques are used to secure the test and debug instrument access. So this we have to take care. We cannot neglect this. And developing advanced techniques to secure the rights of all stakeholders. That is important. And in fact, if we feel that everybody is nice, then there is actually no issues. If you say design house is nice, IP vendors are nice, and user is nice, and so there won't be any issues. But however, as I said, that this is an open resource problem, not only in VLSI design for the hardware security, but however, this is also a design, open resource problem, and people can still take it up when you are doing for the IoT security. So now again, we'll take another 10 minutes break, and this break is important for your attendance. And the time is 8:45, so please check in with your Google form and take care. So Ask and Sir will take care of. So Ayas and Jagannath, this is 8:45, so they probably have to fill it up, their Google forms. All the participants, please look at your Google form, and this was shared in the morning or earlier evening.
Sir, actually we have shared it.
Okay.
And we have opened it for till 9 p.m. so they can give their attendance. And at 9 p.m. we'll end it. I think we'll have a online photo. I will allow camera for all. We can take a screenshot.
Yes, sure. Then I can continue right away. No issues.
Yes, sir. Yes, sir.
Okay. Then it's fine. So this POF is a solution actually, physically unclonable functions. Since I'll not have much time, let us go a little faster. And the security properties here are uniqueness, uniformity, and reliability. So this is what we have to actually check about this one. So we'll design our POPs, and POPs are different kinds. And here we say that uniqueness is measured by the homing distance, and the ideal value is 50%. And again, reliability of the POP. Ideal reliability is 100%, but that is something that you have to look at. Uniformity is again 50%, so that. And this one is one of our research papers, so please, I'll skip it for the timing. If you are specifically interested, then you can have a look. I have given this as a reference, and because I should be meeting you almost every day, so don't worry. And if you have further questions, you can ask it. But I also feel that some of you might have already got a board by talking about an out and out VLSI design, and that to the highest level hardware security. But that's what is the topic is all about. But let us come to little more interesting stuffs. IoT is device security. So where exactly the issues are coming, and the security threats are node capture attacks. So in the IoT also you'll have this. A malicious code injection attack. So you can, and false data injection, and the side channel attack as people extract information and then they try to do so. A denial of service, sleep deprivation attacks, and booting vulnerability and hardware software exploitation. And then this one, whatever I have written down, I have given the particular solution. Some of these we have done it in our labs. Some of them we have borrowed it from literature with adequate information available. So with POF, we can look at this node capture attack. And why I'm saying this, and this would be applicable for IoT because this is being used for with microcontrollers and SoCs. And code injection, again, this will be becoming an issue in IoT is node over the air. And side channel attack, yes. So this also, we can also doing this. And eavesdropping and interference, this is again becoming an issue. Sleep deprivation attacks. So the microcontroller should have mechanism to detect denial of service, because the denial of service is something particularly done by the hardware trojans. So therefore, we won't like to have that particular kind of thing. So we must try to escape from that. And then booting vulnerabilities. So that is there, and hardware exploitation. So these all things are becoming a little bit. So we have this has a direct implication in IoT. And here now I'm taking this particular one example, and this was primarily I must done by one of my ex-PhD student, and he targeted the smart city and smart villages. He looked at both aspects. One is his name is Saswat Kumar Ram. Now he's working elsewhere. He's not with us anymore. Amrita Vishwa Vidyapeetham is working, and so this is basically his entire research, and we have conducted it over here. And of course, when the IC design part and all these things came up, your Askan sir and Jagannath, all of us were a team. Anyway, we looked at the smart cities and smart villages, broad perspective, and this again, I'm repeating smart city and smart village for our country's or nation's voice that we want to build smart cities. But at the same time, we also want to need smart villages. And then the security by design is the key for sustainable IoT. And what are the issues, and particularly we said that reliable and secure EHS. EHS, if I expand, it is called the energy harvesting system because that is the power requirement. So now this is of course a very common thing, that what is a smart village, because smart city is something that we read in the paper every now and then. But smart village is again the same thing. But smart village means these are the requirements that we can have. Smart farming, smart education, tourism, crafts, these are coming mostly from villages. Disaster management, this is a must. Governance again is required. Transportation, we may not have a airstrip, but at least whatever transportation is the healthcare and renewable energy and all these things will be there. Pollution control, etc., etc. And we talk about the security again, because I said that we have to introduce this one, the security. We said that there are two aspects, this one, energy harvesting, and we said the security by design. And this we put it on IoT smart node. Now, if you look at this one, you would say that why energy harvesting is required. The energy harvesting is required because all the IoT nodes need not be in the most comfortable place where the power is available. Or even if power is available, then we try to extract it from renewable energies. And in the present case study, we have used a photovoltaic cells. And then we said that, okay, security. Because if you look at the different wireless sensor nodes, you may not necessarily have power at all the places. Then if we look at this one, this diagram, then we say security by design, and where it is applicable, we say here security in SoC, all the chips that we are designing. Security in vehicles, yes. Data security is another, and life cycle protection for all the ICs that we go for. And this is, of course, done through a POP, physically unclonable function. Security in IoT cannot be ignored. That is what I have been emphasizing from the beginning, and is given an importance as power, performance, and area. In the sense that in VLSI design, we all the time say that what is important, make the size as small as possible, because we want to pack more and more number of devices. It should be as low power as possible. Your mobile phone is one of the examples, your laptop is another example, and you don't want them to discharge, so this must be low power. And more serious examples are your pacemaker, your ICs for tsunami detection, which is placed in the deep sea or in all other scenarios. And speed is something that we are all crazy about that. So let us. And if you look at this is for the VLSI design, but at the same time we also borrowed the same thoughts into embedded. And in IoT also, we are also doing the same thing, that we also look at the size of the device. That's again this one. And the speed. The speed is sometimes important, sometimes not important. That we have to look at. Not important in the sense that if you can wait for your solution, yes, make it. And power, yes, again, depending on the scenario. But in addition to these standard three stuffs, that power, performance, and area, or size, power, and speed, the fourth important paradigm is security. That is what is being stressed over here. And we say that securing IC from attacks. And IC from attacks, don't think that the IC is only VLSI designers' in-house property. They design it, but they design it for all of us. So IoT guys will be requiring this. So we say that this is the POP, as I said, that the challenge and response. And we'll have to look at the uniqueness, reliability, uniformity part in this one. So here we made an attempt to design an energy harvesting system with on-chip security. So we gave unique ID for this one, and we designed a POF. RO we have done, ring oscillator POF. And there is another aspect that we have tried over here, this MPPT of EHS. We wanted to extract the maximum power point tracking for the energy harvesting system. And also at the same time, we also said that this is the counterfeiting aspects in the VLSI design. We say that whether we are having a aged IC or a recycled IC, that we have to do. As I said that we have to handle this at the test level. So this was the unclonable key for enabling ring oscillator and MPPT. This is what, this being a research problem, I'll not get into except for the points that whatever is important for us, we'll get into that. So we said that the multi-level security for our energy harvesting system using physically unclonable function, and that we have done with two different POFs, RO POF and latch POF. And in the EHSs, we had two typical module, one for the security, another for the maximum power point tracking. And this one is the algorithm for doing that. So, and this is again this POFs. And then we developed a mechanism for detecting the recycled energy harvesting system ICs. So this is from the counterfeit aspects, that how did we manage to get this. And when I'm telling this, my only point that I'm talking is that we looked at one application called Smart City or Smart Village. And there we said that we are trying to build certain amount of security. And when the country is looking at building the smart city across the whole nation, then obviously we'll have to look at this one. And our message in this particular case is only that, yes, there are solutions. We have to look at this one. So we have been able to detect this. And this is the IC that was done. And then we said that the reliability part for the IoT node. And the reliability degradation is coming out from the various scenarios here. Tracking time of MPPT. MPPT has to be used. You can't say that you cannot use MPPT. You may use whatever techniques. We have used P&O technique over here. And the ripples at the output due to the fluctuation in the supply voltage. And similarly, there is a possibility that, yes, hardware trojans, if at all, coming. Again, coming as a problem. I'm almost done, so please wait for a while. And then we have designed this, proposed reliable, secure solar EHS system. And then how did we manage this particular design? We have said this. Now, coming to the fact, if you look back just 10 years back, then there was not much of research going on in this particular hardware security. And obviously, IoT was not really much in picture. Although we are indirectly using somewhere or other IoT stuffs, but then suddenly this And so that is why we said security has become another tenet that is in the chip design, along with these three standard aspects when we talk about size, power, and area. And what I said in the security awareness in every step of chip design will be there. But at the same time, when we said that security will be for these things, but at the same time, I said that it will directly or indirectly address the problems in IoT edge device security. So the point that I'm trying to stress upon here is that in IoT, we are going to use hardware and mostly the embedded processors and embedded systems, and they are vulnerable. And when they are vulnerable, we don't have a choice. Our whole great thoughts that we are pushing ahead. I just gave you one example talking about smart city, but it is almost everywhere now we are doing this. We say that a smart irrigation system, example in agricultural IoT, we say a crime assistance system in vehicular IoT, or lots of stops in healthcare IoT, in industrial IoT for improving our uh, productivity. But if at all there will be some kind of security issues, then all these big things that we talk, it will become a problem. And the only solution is that whenever we start designing, we'll have to look at also to the security that is except the standard ones. Whatever we have done, we may say that we have done a great design. If you neglected security, you are gone. So we'll look at the security. So today I just tried to highlight the overall aspects that, and I tried to touch upon almost every aspect in the hardware security. And this is a great research area. If anyone is interested, can take it up. And IoT and security is again another great research area. And there are open-ended problems also still there. So that is what I wanted to cover up, except the references I have not shown, but the references, as I said, um, I have mostly done the research that we have done in our labs, not much. The other cross references can be found out on a later part. So thank you very much. And if there are questions or if there are hands raised, then I'll be answering you.
Thank you, sir.
Thank you, sir.
I have made them or allowed the mic to participant, so they can unmute them and ask the questions. And there was a question from Professor Pankaj Joshi. Are you there? You can unmute yourself and ask the question. Professor Pankaj Joshi.
Hello.
Please.
Sir, I think I have raised the question before this session and that you have answered with this session.
Okay.
Okay, thank you, sir.
Okay, thank you. I understand that this hardware security is a little offbeat topic, but then because this is important, we also felt that this should be discussed. And along with me, there will be many speakers who will be dealing this one. Professor Anirban Sengupta will be there one day. Madam Urbi Chatterjee will be there. She will also discuss on this. Professor Ashok Tiruk, our in-house expert, and Vibhu, he's also our in-house, Professor Ayas Khan. So they'll all be dealing with this one. Please try to realize that this is an important aspect. While we still carry on with our IoT, but IoT is fine, but as I said that our whole thing will be jeopardized if we do not take enough care as regards to the security. Okay. See, as you know that there was a time when people were only concerned about virus, they said virus, and then suddenly people started using that Windows is this problem, and then Windows have evolved over the years, and Linux was more stubborn, so also Unix. And that time nobody thought that there would be anything called hardware issues or hardware trojans. But suddenly it came up, and industries faced those issues. And now all of us are likely to face issues because, and we have to build protections against that. Anyway, if you have no questions, please go through the lecture. Askan sir will share you that entire PPT. That's not an issue. I can give it. And since I'll be meeting you almost every day, me and Askan, so you can still ask questions to us on all the days. Not an issue. Any more questions?
Yeah, hello. Am I audible,
Yes,
sir?
sir. Yes, please.
Just sir, I have read somewhere like the hardware accelerator. So how the hardware accelerator can be useful for IoT devices?
See, please try to understand that security is a requirement. And the security can be provided in two approaches. One is the software approach, this I told, and another is the hardware approach. When I said software approach means there is a processor which is doing your job, which could be an embedded processor, and it is doing your job. But now I have to add additional lines of coding into that so that the security part is being taken care of. See, whenever we are saying that we are doing an IC design, remember if you are trying to design it through Verilog or VHDL, that is something that many of us are trying to do in that way. So you write codes. So there you have to add additional codes which will take care of that. But imagine that is an IoT processor. This is already an existing processor, and we are adding extra lines to protect against the threats. But what I said that whenever we will go for the hardware security, we will provide an additional IC exclusively for the security. Additional IC means sometimes many people would say that, are you going to provide this processor and another additional processor? The answer may not be no. But the point is that also you can do. Also you can do that whenever you are designing the processor, build that exclusive part of your IC as a security portion. And that part will be exclusively taking care of all possible scenarios of attacks and taking care of the security. So that, because we have said that there are so many solutions, and many solutions are coming at the time of testing, that we have to incorporate additional tests. But the thing is that if we provide right from the beginning, and the tests are possible, so that it is will facilitate in a better way compared, because this is a dedicated one compared to the processors where you can add codes and then try it, then the performance will degrade.
Okay. So it means like if we're talking about the ASIC design flow, so did it follow the traditional flow, or we have to add some additional in the design flow?
No,
like when going for
we will follow the traditional design flow. I'm not saying that you change anything. See, you go by semi-custom design. whether you are doing by the standard cells or gate arrays, the same approach you will proceed and do this. My only point is that suppose I say that I have got an IC where I have got 100% area. Maybe 20% area I will specifically designed for the security part. And that part will be exclusively covering that yes, additional coding would be done there. So which was not there in a processor that was already designed. And there we are trying to say that we are adding extra line of coding through software that this will take care of that. I'm not saying that that cannot take care. That will also take care. But there is a possibility of failures which are more. But here, as I said, that right from the day one, when you are, see, we are following the standard ASIC design flow, because that standard ASIC design flow is giving us speed, is giving us power, is taking us lower area and everything. But we also say that our fourth tenant is also available. Security is also there. So that we have to insert into the IC. We'll follow the same method. We're not following anything different. But imagine that already an IC is designed. You will say that, how do I manage this? Okay, you put another piece of hardware there over there, and then try to save your original IC from the one. But if at all you are doing a new design, then you say that along with all this, this part of the component will also be taken care of.
Okay. Thank you, sir. Very good.
Okay. Actually, one of our ex-student also, Mr. Sudhindra, sorry, Dr. Sudhindra Kumar, he is in PESIT, Bangalore. He will come up at least for a couple of one lecture and another hands-on session and all that, both in online as well as in offline. So, in fact, you will see his references also, and he will also talk about the last point that we are raising. We are not changing anything. We are saying that few extra steps we have to take. Okay.
Okay, yes, sir. Okay, thank you, sir.
Okay, thank you.
Is there any other question? So if no question is there, I'm just making camera on for all the participants, so we can have a group screenshot photo. So can you please switch on your camera, all of you? Okay. Okay, thank you.